Parametric spiral finishing is a new strategy to create parametric spiral toolpath which flows from a pattern to a check surface. It is similar to the existing 3D offset strategy and the new flowline finishing strategy, but there are three main differences. Parametric spiral can work on triangular models as well as surfaces. It can machine some undercuts and flow to a base plane. For example, when we look at this fixture in front of us, we'll turn on the undercut shading. We can see there are areas identified on here which have distinct undercuts. The boss area at the top is of particular interest for using with parametric spiral. I can see the hole on the top goes through, and this needs to be capped before we can do our strategy. I'm going to go into a front view, revert back to normal shading, zoom in, and now select the surfaces. Over the feature set, I'm going to ask it to recognise the holes within those selected surfaces and click apply. When that has been done, I'm going to choose the appropriate feature set. I can see that's number 1. By right clicking, just cap the holes off, and that's done. Once we've created the capped holes, we're now going to create the start pattern. Parametric spiral machines from a pattern, and we're going to create this using a point which is positioned in the centre of this capped surface. So within the pattern, I'm going to go into the curve editor, create a point, position it in the centre, and accept. Once I've created the pattern, I need to create now some limit surfaces. Now I can put these either onto a level or a set. In this instance, I'm going to put them onto a set. By selecting the surfaces, by dragging the cursor, these areas where I suspect there are small surfaces will easily be selected. Thus, I can now acquire these to the selected set. That's done. Once I've done that, I'm now going to create a boundary using a sketch, using the new functionality of Bezier curve. To create a smooth curve that goes around the area I wish to machine. This will be used to control a local material block. Select the boundary. I can measure from the surfaces 228mm to 246. Once that's done, I need to create the new strategy. We find that under finishing, parametric surface finishing, first thing, as normal, give it a sensible name. So I'm going to use a 5mm ball nose, so I've got BM5, and PS just as a marker. I'll select the central pattern we've used, and now the check surfaces, which we put onto a set. The angle is the maximum permitted undercut angle that I wish to machine. In this instance, on this machine tool, I'm going to keep that 15 degrees. I want to reduce the tolerance, keep it incline milling, and just put in a step over of 0.25mm. I'm going to select my tool from my tool database, which is the standard 5mm ball nose. Close the form. I'll now go into tool axis. Happy with that being automatic. I want to apply some leads and links. I'm using an automatic tool axis, the first thing I'm going to do is use a surface normal arc. It's 45 degrees, 3 millimeters. The same for the lead out. Apply a suitable rapid move height and a plunge clearance height, and I'm done. I can now calculate the toolpath and view the results. If when using this strategy no check surface is specified, then the bottom plane of the block is considered as the check surface. And also, when I looked at the tool axis, I've used automatic in this instance. All tool axis definitions are available for the strategy, however, only a spherical ended tool can be used if the tool axis is set to anything other than vertical or automatic. Having created that toolpath, I'll cancel it. We'll view in the top view, we can see it's created a nice even cutter path. Look from the front, again nice levels. If I right click and simulate from a nearest point and turn on the simulation, we can see now how the tool axis moves as it goes round the job. That is parametric spiral. When we use other geometry items other than points in defining our central curve, when we define our parametric spiral finishing toolpath, other options become available for defining the undercut areas to be machined. I'm now going to demonstrate an alternative toolpath creation using the same features used previously, but now using a line instead of a point. Create the pattern, same as previously. When we go into the curve editor, I will now create a line. This line will exist somewhere near the center of the boss. I'll click accept. When I clone the previous toolpath, I'll rename that to line, and I look at the settings, I will change that central curve to the line. But when I view the boss from the front elevation, I am now going to use the interactive hyperlink to measure the desired angle on the undercut. By clicking once, it's entered in the measured angle of 11.9 degrees. I wish to give some clearance to that. I'll define 14 degrees. But I wish to maintain a 0 degrees undercut to the right hand side. What this will mean is that the tool axis should remain vertical on the right hand side and go up to 14 degrees of undercut on the left hand side. Typically with this parametric spiral finishing toolpath, we'll either use an automatic or a lead lean tool axis. I'll maintain the automatic so we can see the comparison to the first example we did. I'll click calculate. The toolpath that's being created has now given us an alternative tool axis position. If I was to position the tool on the right hand side, we'll now see that the tool axis is vertical. But when we go round to the opposite side, we will see that the tool axis is going by up to 14 degrees. Turning on the display, we will see as the tool goes round, we look at the axes, we can indeed see that on the right hand side the tool axis goes at 90 degrees, stays in a vertical tool axis orientation. When we come to the undercut condition on the far side, we have a maximum deviation that's well within our 14 degree limit. This is the alternative method of gaining more control over the tool axis orientation with parametric spiral finishing.